Alright, so welcome to the 12th tutorial session of problem solving through programming in C. Like I said, this is a SWAYAM course floated by Professor Anupam Basu from Department of CSC, IIT Kharagpur. And I'm Siddhant. I'm the TA who is in charge of taking these tutorial sessions where we'll be discussing the concepts and a few questions which will help you out with the final exam as well as the assignments. So here we will look into the concepts and the questions of week 12. So week 12 we looked at structures. We also had a look at dynamic memory or dynamic memory allocation and of file handling and a bit of miscellaneous stuff. So let us just get into the questions. So first we'll look at a few questions regarding structures. So this is as you can see, this is more of a theoretical question. So let's see. So the question asks, what is actually passed if you pass a structure variable to a function? So the options are the copy of the structure variable, the reference of the structure variable, starting address and ending address. So which of the following do you think when you try to pass a structure to a function? So what usually get passed to the function? So structures are generally passed by call by value. That means you will pass a copy of the structure variable to the function. So whenever you just call a function with some struct, say my structure name is some S1, okay, and then the variable name is some var1. So if you call the function like this, so basically you are sending this variable, this structure variable, a copy of this structure variable to the function called func. So it is following the rules of call by value. So a structure variable, whenever it is passed to a function, you pass it by call by value. That is, you pass a copy of the structure variable to the function. Okay. Alright, now is it possible for us to define a function inside the structure? Has anyone tried doing that? So the default thing for structures is like you define a struct, say the structure name. Inside this I define my say int var1, some float var2, char var3, so different variables, and this is my structure, right? So this is how I define a structure. Now is it possible for me to also define a function inside the structure? So what constitutes components of a structure basically? So a component of a structure can be any data type. Okay, so basically int, floating point, boolean, char, string, all of these data types can be a component of a structure, but a function cannot be a component of a structure. So we cannot define a function inside a structure. Okay, we can pass the structure to a function which is written globally, but we cannot really define a function within a structure itself. Okay, you can only define data types and arrays and so on. So you can define int, you can define floating point, character, strings, and boolean and so on, but no functions. Okay. Alright, now let's look at some more detailed question or structure. So here we have a structure called student. So this is the name of the structure, student, and it has only one component, which is a character. It is a string, right? You define a character pointer. That means you have defined basically a string. You can store multiple character values there. So the character, the structure student has one component, which is a string called name. Now in the main function, you are defining two structures, s1 and s2. Okay. So why I have written it like this, struct student s1 s2, so because I have not used type def. So type def is used to create user defined data types. Creates user defined data types. I have not used type def here. So I have to write the entire thing, struct student, then the variable name, that is s1 and s2 here. So s1 dot name, we are setting it to stu, okay, and then we are doing s2 equals s1. So this is a assignment operation. That so the basic I can tell you is that we define a structure which is a set which can consist of different components. Like here you have a structure called student. So inside student I have defined, say, a name. So I have defined a character array, which is basically name. Now I can also define, say, floating point numbers. Say I want to store the marks, so I am defining a variable called marks. So these two are components of the structure called student. So these two are the components of the structure called student, and I can access each of these components. So whenever I define some variables of this type of structure, so I define the variable, say here I define struct student s1 and s2, like it has been done here. So I can access the components of s1 and s2 as s1 dot name and s2 dot marks, okay, and s1 dot marks, and so on. Okay, so every variable that I define of the type, this structure, which is struct student, has two components, which is name and marks. Okay, so that is what has been done here. So what I am doing is, so when I am defining this s1 and s2 variables of type struct student, so this s1 has two components. Sorry, it has one component here, because it has we have only defined one component, which is basically a character array. So there is s1 dot name and s2 dot name. Okay, now we are saving in s1 dot name, we are saving the string stu, and then we are using a assignment operation, s2 equals s1. Okay, now what this assignment operation should do is, for any variables, like general variables, it would copy the value that is stored in s1 to the variable s2. Okay, that is what it would do normally. So what happens in case of structures? Can we do the same thing in case of structures as well? So after that, what we are doing is we are printing using percentage %s, which is the format specifier for strings, and what we are printing is s1 dot name and s2 dot name. So name is a component of this structure variable, which is s1, and this is how we access those. We access the component of the structures. Okay, so what should be the answer here? Why do you think so? Okay, but it is actually possible in structure. So assignment operation is legal. So that is a good thing about a structure. So assignment operation is valid or legal. Okay, that means if it is, so it needs to be a structure of the same type. So here we have a structure of type student. So that means it has only this one component called name. Okay, So when we write s2 equals s1, basically what it will do is it will do s2 dot name equals s1 dot name. Similarly, in this case, it would have done, if we wrote s2 equals s1, it would have done s2 dot name equals s1 dot name, and s2 dot marks equals s1 dot marks. But if you are trying to, you have two different structures. Say I have one structure with only the component as name and the other structure with component name and marks, and I'm trying to do assignment operation, then it will give you a compilation error because the structures are not the same type. So they need to be compatible in order for you to do the assignment operation. The two structures must be compatible. So basically it should be the same structure, so it should have the same components and in the same order, the same components in the same order. Only then uh, it you can do this assignment operation. So in this case, both are of the same type, which is struct student. And what will happen when you do this is s2 dot name will take the value which is stored in s1 dot name, and that is this string, which is stu. So when you print using this percentage s1 dot name and s2 dot name, you will get stu space stu. Is it clear now? Yeah. So I was talking about type def earlier. So say if you don't want to write this struct student all the time, right? I don't want to write both of these words. I can define a user defined data type then. So what I would do, I would write type def struct student. Okay. So type def basically means that I'm trying to define a new data type here. Okay. And then inside I do whatever components I want to keep. So I just keep the components over, then I write what tag I want. So basically this is the tag, this is my new data type. Okay, this is my new data type. I can have it set to say st, stu, whatever, but I have written student here. So when you want to declare or initialize new variables, declare new variables of the type struct student, you can simply write student s1 comma s2. So this would define like two different variables of type struct student. But I don't need to write this keyword struct anymore because I have used type def, which is used to define user defined data type. So here I am saying that whatever structure I am writing here, which is this struct student, I am defining it as a new data type which is called student. So now I can just use this word student to declare new variables of that type, similar to how you do int x, int y. Similarly, you can just write student s1, student s2, of that manner. So that is the purpose of type def. So the type def keyword, so it you can use it to create user defined data types. Okay, all right. If Yeah, let's look at the next question. So here we have a structure which has been defined inside the main function. So this is also valid. I mean, there is no issue with defining a structure inside the main function or inside any of the functions. Okay, so the scope of this structure will be only inside main. Okay, so that is what is important. So scope of the structure, like we were talking about scope earlier in, I think a couple of weeks back, we were talking about the scope of variables, right? So here similarly the scope of this particular structure is limited to main function. Okay, now we have defined the structure struct inst, and inside that we have set we have one int, that is one integer variable, and one character array or string, you can call it a string rather, and we are initializing we are giving some initial values to the components. So to the integer x, we are giving a initial value of 2, and to the string we are giving a we are initializing to IIT. Okay, now this is our structure. We have defined the structure. Now we define a variable of the type struct inst. Okay, so s1 is the variable. This is the variable that we have defined, and now we are trying to print using the printf function. We are trying to print each of its components, which is s1.ins, which is our string, and s1.x, which is the integer. So what should be the output here? So this will, you can check here. So s1.ins, what is it? It is a string, right? s1.x, what is it? It is an integer. Now for string we are supposed to use percentage %s, and for integer we can use percentage %d or percentage %l or whatever. So however, this is correct, we have used percentage %d, but you can see that s1.ins is a string, but we have used percentage %d here and not percentage %s. Okay, so that will give us an error, because percentage %d is used for integer values. It cannot be used for strings. So in that case, you will have an error here, which will basically be saying that percentage %d is not compatible with string. Okay, is it clear? IIT space 2, or I mean there shouldn't be any space here, because in the question there is none, so it will be like there is no space here. Okay, so it will be IIT2, like IIT2, something like this, if there is percentage %s. Yes. No, there is no error regarding that. Just that the scope of the structure. So you cannot define a. So let's say you have another function, some func here. You cannot define a structure variable struct inst, say s2. This will be wrong, because the scope of this structure is only limited to main function. Okay, so if you define another function, so you cannot declare a structure variable of type struct inst inside that function. It is that will also give an error. But this, as such, it is correct. The scope is limited to the main function. Is that understandable? Okay. Okay. So on to the next question. So here what we are doing is we are defining this structure. So this is the structure definition. You can see here. This is the structure definition. Why? Because we are giving the struct keyword, the name of the structure, then within curly braces we are giving the component, which is int_a. So this structure is of type struct xyz, and it has one integer component or integer variable called a, and then we are terminating that with a semicolon. So basically this is the structure definition that we are giving. Now we are defining a structure variable called obj1, and we are initializing the component, whatever component it is, to 11. Okay, similarly we are defining a structure variable obj2 and doing an assignment operation with obj1, and we are trying to print obj2.a, and we are setting obj2.a to something else, and we are doing a couple more of print statements. So what do you think should be the answer here? Okay, Okay. So let's see what happens first. So uh, initially we have obj1 dot a set to 11. This is how you initialize. Okay, because you have initialized a value of 11. So if it had say multiple things, so int a, int b, and so on. So let's say this was your structure, and you had defined the structure variable var1. Okay, and I could give values of say 11, 22. This would be one structure variable. If I had to define like a array of structures, some array of size 2, let's say of size 2, so 11, 22, 33, 44. Okay, so that would have created basically var0, which is a structure variable of, so this is a structure variable of size 2. That means not size, I would say number of elements 2. So var0, the 0th element of this structure, would have again two components. A value would be 11, B value would be 12. Then var of 1, A value would be 33, B value would be 44. Okay, so this is how you initialize a structure or an array of structures. Okay, so here obj1.a we are setting it to 11 because like we are initializing to 11. Now this statement, what it does, it just sets obj2.a also to 11 because it just copies the value of the components of obj1 to obj2. So obj2.a is also 11. Now you are printing that. So 1 1 will be printed, which is the same in all the options. Now next we set obj2.a to 101. Okay, and we print obj1.a. So obj1.a is still unchanged because you are not changing the value of that structure. You are just the only operation you have done is copying the value of the components of obj1 to obj2, but you're never changing the value of the components of obj1. So it is still the same, it is still 11. So you're going to print 11 again. Okay, and then obj2.a, when you're printing that, you have changed the value to 101, so you will have 101. So option B will be the answer here. Is it clear how the answer came up to be option B, and how to, yeah, yeah, and how to initialize the structures and array of structures? All right, so let's look at the next question then. So here we have uh, yeah, so here we have an array, sorry, not an array of, yeah, we'll have an array of structures, we'll see that. So we have defined a structure P with one integer value and one character value x. Integer value is x, or integer component is x, and character component is y. Now inside the main function we are defining this variable, which is p1, which is an array of structures. So this is a array of structure struct p1, struct p. Okay, array of struct p. And like I said, how will it get initialized? So this, so 1, 21, 69, 42, 64. So how will it get initialized? So this will be, the first one will be p1 of 0 dot x. This will be p1 of 0 dot y will be 21, but because it's a character, it will be the ASCII equivalent of this, okay, of 21. So basically it will be a char 21. Okay, now p1 of 1 dot x will be 69, p1 of 1 dot y will be again 42, but ASCII equivalent again. Okay, that means char of 42. Now p1 of 2 dot x will be 64, and p1 of 2 dot y, you have not specified anything, so it will be 0. So basically char of 0. Okay, so basically you're defining a array of struct p with 3 elements. Okay, so 3 elements, that is 0 at index 0, index 1 and index 2, and the values are so on that you have initialized. Now then you define a pointer to a structure, and you are setting to p1. That means what you are doing, what will this pointer ptr1 point to? It will point to the first element of the array p1. Okay, ptr1 will point to first element of array p1, like it normally does for any variables apart from structures. It will be the same for structures as well. So ptr1, the pointer, will point to the first element of structure p1, which is this 2, right? This is the first element. All right, now you say that int x equals size of p1 by 4. So how much is that? Size of p1? I think I covered this in the previous class towards the end, if anyone remembers. So, and what is that? So p1 basically has 3 elements. Okay, it is an array of structures with 3 elements, and each element occupies how much space? Why 4? No, that is, you are confusing structure and union. Union is a different concept. Union will take the maximum size of the components among the components. But we are talking about structures here. So structures, okay, we'll see this one. So basically we are dividing the size of P1. I'll say that the size of P1 here will be 3 into 4 into 2. It will be 24 bytes. Just think about it. Why? Now then x will be 24 by 4, that is 6, right? 24 by 4, that will be 6. Now so x equals, you will have size of int, which is say 4 bytes, and size of char, which is 1 byte. So here it will be true because this is 4, size of int is 4, plus twice of size of char, which is 1, so 4 plus 2, 6. So x equals 6, which is true, so it will just print true. Okay, so that is the output of the following code. Now why does it save, why am I saying that the size of this structure, array of structures, is 24 bytes? So it's something to do with concept called structure padding. Okay, I'll talk about this just now. All right, so in the previous question we had an int and a char, which is dissimilar data types. Okay, now let's draw this. So this is 4 bytes, which is for int. Okay, so all right, so so the int x occupies 4 bytes. I'm talking about 32-bit systems. Okay, I'm assuming it's 32-bit system. So int x occupies 4 bytes, and one character will occupy 1 byte. So what happens here when I define this character? What was this? P1, right? P1, and I have how many? 1 comma 21 comma 69 comma 42 comma 64, right? This is what I have defined. This is my array. So this is first element. Okay, this is second element, and this is third element. Okay, so the first element, why I'm saying 3 elements here instead of 5, someone has asked that in the chat box. So why I'm saying 3 elements is because it is a array of structures. Okay, it's an array of structures. That means every element of this array is a structure. is a structure data type. Okay, now if we count like that, then the first element comprises of the first two, because there are two components for every structure, that the structure that we have defined, there are two components, right? One int and one character. So we are defining the first element, this the first element as the first two values that we are initializing, the second element as the third and the fourth value that we are initializing, and the third element only we are initializing one value, the other one will be set to 0 automatically. Okay, now how it is saved in the memory, let's look at that. So let's say it is an array, so basically it is a contiguous memory location, right? It all the three structures will be stored one after another. Now let's see how it is being stored. So the first component of the first element, which is saving the value of 1, it occupies 4 bytes. Okay, and then we'll divide first the entire system into 4 bytes. Okay, let's see how that happens. Maybe I'll start a bit earlier from here. Yeah, all right. So one of this is 4 bytes. So the first element, which is 1, will be stored here. Okay, in this 4 bytes, right? Now next, you have a character which is y, which is occupying 1 byte and storing the char value, that is the ASCII equivalent of the value 21. So that will occupy only 1 byte, right? This, it will occupy only this. What is being stored here? It is the char of 21. That is what is being stored here. And there are still 3 bytes left. So these 3 bytes are called buffer space. So they will stay empty. Okay. Now next, our next second element starts from here, and in the 4 bytes we are going to store the value of 69, which is the first component. The second component is 42, which is the char of 42 actually, because we are trying to save into a char variable. So that will again occupy only 1 byte here. Here you will save char of 42, and there will be again 3 buffer bytes. Okay, then the third element is 64. We save 64. Then the second component is automatically 0, because you have not really given the second component of the third element, so it will be set to 0. But because it's a char value, it will be stored only here, only the first byte, which is char of 0, will be stored. Now this 3 again will be 3 buffer bytes that will be empty. So the total space that will be consumed, this is your first element, this is your second element, and this is your third element, right? Every element, how much is it occupying? 4 bytes plus 1 plus 3, that is 8 bytes per element, right? So the total will be 24 bytes. Now why is this padding required? Okay, why do we need to give this structure padding? Okay, it is to decrease the number of CPU cycles. So the objective is to decrease the number of CPU cycles. What does that mean? So 32-bit systems can read 4 bytes at a time. So that is the default set into the CPU, that 32-bit processors will be able to read 4 bytes at a time. Okay, it cannot read like in between, like 2 bytes here, 2 bytes there, it cannot read. So consider a case where you will have, say you are using this char variable, you are defining a first a char variable, so this is char. Okay, next you have an integer variable, or you have another char variable. Okay, this is again another char, and then you have an integer variable, right? If I define like that, so these two are supposed to be integers, but integer occupies 4 bytes of space. If you remember, integer occupies 4 bytes of space in 32-bit system. So you will have to divide it between two different bytes. So if this memory location starts from 1000, this will be 1004, and this will be say 1008, right? So your next integer, when you are trying to save, it will be saved partially from 1002 to 1004 and 1004 to 1006. Okay, so what will that cause is the CPU can only read from 1000 to 1004, 1004 to 1008. Okay, so it will have to read this int value in two cycles. First, it will read this 1000 to 1004. It will take out the char values and partially the int values. Then it will read 1004 to 1008. It will again take out this in partial integer values from here. Then it will merge this two and give you the final integer value. So that means you have used two CPU cycles to do the same thing that you could have done in a single read here. Okay, for reading one int, and you are dividing that to avoid this kind of dividing the like the bytes among int or even higher data types. We use this structure padding. So here it's fine with us if we leave 3 bytes of space empty, but we want to keep this 4 bytes, like all the variables as 4 bytes and so on, so that it is easier for us to work with, for the CPU to work with, not us but the CPU to work with. So for each of the elements of this array, there will be 3 bytes of blank space. Okay, and this occupies 5 bytes, and there will be 3 bytes of blank space. So that will give you a total of 8 bytes per element. There are 3 elements, so total will be 24 bytes. Is it clear now? So this is called structure padding. So like I said previously also, size of a structure is greater than equal to the sum of size of its components. Okay, so what does that mean? That uh, so if you have a structure, so let's say you had a structure of one integer and one character value. So the size of this structure, however, can be greater than the size of the sum of the size of the element. So here you saw that the size of the structure is 8 bytes, while the sum of the size of the elements is 5 bytes. So it is possible because of this paradigm called structure padding. Now in which case it will be equal? It will be equal when there are similar data types here, like you have int x and int y. So both of them are 4 bytes. You don't need structure padding. So there it will be a total of 8 bytes, and the size of the structure will be 8 bytes. Some of the component sizes will also be 8 bytes. So in that case it will be equal. But if you have dissimilar data types like this, there will be internally the structure padding will happen, and you will have the size of the structure being higher than the sum of the size of the components. Is that a bit clear now? Okay. So if that is clear, then let's look at this question. What will be the size of the following structure in bytes? So here we have a char, an int, and a double. So I'm assuming that it's a 32-bit system here. Okay, that means char occupies 1 byte, integer occupies 4 bytes, and double occupies 8 bytes. Okay, so let's see how much this results in. Can you calculate that? All right, so why I said it's a 32-bit system, because that basically means that it can read 4 bytes at a time. Okay, so it can read 4 bytes at a time. So that means the padding will happen such that we will avoid we will keep all the variables in 4 bytes as as multiples of 4 bytes. Okay, it should be all the variables or the sizes of the component should be multiples of the 4 bytes. Okay, so here this the character is the first component taking 1 byte. So what will happen, let's draw that out. So I am drawing 4 bytes, sizes of 4 bytes. Okay, multiples of 4 bytes. So let's say this is 4 bytes of space. The first one will save this character C. 3 bytes will be buffer. Okay, there will be 3 bytes of buffer. Then we will store the integer I. Okay, 4 bytes. Then we'll store the double D in both of this because 8 bytes total. We need to store. This will be integer D. Sorry, double D. So how much did you take? You took 4 plus 8. That is 16 bytes. Total 16 bytes of space. Why this happened is because double, it occupies 8 bytes, which is like a multiple of 4 bytes. So anyway you will need 2 CPU cycles to read a double data type. Okay, because the 32-bit system can read a maximum of 4 bytes at a time. Okay, it will read 4 bytes at a time. So to read the double, you need 2 CPU cycles because it occupies 8 bytes. So you will need to read this 4 bytes first, followed by this 4 bytes. So total of 8 bytes. Now the double will require 2 CPU cycles, and hence you need only padding with the character because it is less than 4 bytes, right? So you will need only to do the structure padding with the character data type. Okay, so here it will occupy this structure will occupy a total of 16 bytes. Yeah. Okay, if we define float here, okay. So if we define float here, it will still be the same because float in 32-bit systems, float still occupies 4 bytes in 32-bit systems. Okay, so basically it will take up this first 4 bytes. The second 4 bytes will be for I integer, and the next 8 bytes will be for the double D. So it will still be 16. Even if you declare a float instead of the char, it will still be 16. Is it clear? Yeah. Okay. Okay then. Similarly, for 64-bit systems, it can read 8 bytes at a time instead of 4 bytes, which was in 32-bit systems. In 64-bit systems, it will read 8 bytes at a time. Accordingly, you will need to do the structure padding. So if you have only a character data type which occupies 1 byte, you will have to do 7 bytes of buffer because it can read 8 bytes at a time. You will need 7 bytes of buffer and then followed by an integer. Integer is 8 bytes in a 64-bit system. So you can read the integer directly, and followed by double I think is 16 bytes, so you will need 2 cycles. So it will be 16 plus 8 plus 8, which will be 32. So 32 bytes of space in a 64-bit system, the same structure will occupy. All right. Okay. So let's go to the next question. So now we have a few miscellaneous questions. The first one is we are defining a function called fun, which takes an array as like we are passing an array by reference to the function fun. We are incrementing the pointer by 1 and we are printing the value of ARR 0. Okay, now we are defining in the main function what we are doing, we are defining an array of 3 elements 5, 10 and 15, and we are passing the array to the function called fun, and we are printing ARR of 0 and ARR of 1. Okay, now what will be the output of this particular snippet? So basically when we are defining this array 5, 10 and 15, this ARR is basically a pointer which is pointing to the first element of the array, which is 5, right? And we are passing this pointer to the function called fun. Now in the function fun, what we are doing is we are doing ARR equals ARR plus 1. That means the pointer is getting incremented by 1. So instead of pointing to 5, it is now pointing to 10. It is now pointing to 10. Okay. And when we are writing ARR of 0, it is printing what? ARR of 0. So ARR of 0, how can you rewrite this in pointer notation? You can write it as star of ARR. Now what is ARR plus 0? Okay, like this. And what is ARR pointing to right now? Basically that means whatever ARR is pointing to, give me the value of that. So what is the value that ARR is pointing to? That is 10. So 10 will be printed first. Okay, now this function is over, it's done. This should be of a void type because it does not return anything. Yeah, so now it prints 10, right? And then in the next statement you are printing ARR of 0, which is again star of ARR plus 0, and then ARR plus 1, which is star of ARR plus 1. Okay, now is this ARR same as this ARR? What do you think? So the ARR that is this in the function called fun, is it the same ARR as that in the main function? The ARR in the main function? So we have seen questions like this before, right? In a few of the earlier weeks. So it's the difference between the sorry. Yes, they are different. So the one that is in the function is called the formal parameters. Okay, this is the formal parameters, and this is the actual parameters. Okay, now they are different variables. Although you have named the same, this ARR which is inside the function called fun is different than the one which is in the main function. So even if you increment the pointer here, you increment the pointer by 1 here, this ARR, it will not affect the original pointer which was there in the main function. Okay, so it is still pointing to 5. So this is the pointer which is in fun. Okay, it is pointing to 10. It was pointing to 10, but the pointer which is in the main function, that is still pointing to 5. Okay, there is no increment that has happened to this pointer variable. The increment that happened was to the pointer variable which was defined in the function fun, that was incremented by 1, but there has been no increment to the pointer variable in the main function, so that is still pointing to 5. So when you say ARR of 0, that will give you a value of 5, and ARR of 1 will give a value of 10. So the answer will be 10, 5 and 10. Is it clear? So ARR equals ARR plus 1 basically means that you are incrementing the pointer to the next memory location. That means it will go point to the next element. So when you initially pass this ARR to the function called fun, this ARR of fun was pointing to 5, because that is what the ARR in the main function was also pointing to. So it was initially pointing to 5, but when you wrote ARR equals ARR plus 1, it went and pointed to the next element. So that is what it means. So the pointer we are just incrementing to the next element. It will go and point to the next element of the array. So here the next element is 10. So this ARR inside the function fun will point to the value of 10. Yeah, so ARR 0 basically means ARR plus 0. That means if you write this in the pointer notation, it is the same as star of ARR plus 0. And what does that mean? So increment the pointer by 0, increment the pointer by 0 and give me the value at that location. So pointer increment by 0 means do nothing, right? And value at that location means it wherever it is pointing to, and where it is pointing to is it is pointing to 10. The second element is pointing to the second element because here you incremented the pointer. We incremented the pointer by 1, so it was initially pointing to 5 when we called this function initially. This was this ARR here, the formal parameter, it was pointing to 5, that is the first element, but then we incremented this ARR which is inside the function fun by 1, so now it started pointing to the second element. Okay, and then we ask that what star of ARR plus 0, that means increment by 0 and tell me what is the value at that location. So increment by 0 means it will not increment, it is already pointing to the second element, and I'm saying increment by 0, so it will do nothing, and then give me the value at that location. So value at that location is 10. Is it clear? Yeah, yeah, if you remove ARR equals ARR plus 1, then the output will be 5, 5 and 10, because it will not be incremented, it will not point to the next element, so it will still keep pointing to 5, and then we'll increment it by 0, that means nothing, and then star of ARR, which is basically the first element, which is 5. So it will be 5, 5 and 10. Okay, any other questions related to this particular problem? All right, so now let's look at the next question. So we have an integer variable a which is set to the value of 10, and we have a pointer star p, and we are saying that p equals ampersand, which is the referencing operator, 10, and we are trying to print the value at p, the value that p, the pointer p is pointing to. Okay, so what should be the answer here? Yeah, right. What do you think so? Why do you think so? Right, right. So whenever you use the referencing operator ampersand, it should be accompanied by a variable, that is a memory location. So 10, the value does not have a memory location. This is a value, right? This is does not have a memory location. So it's a concept of R value and L value. I'll not go into that, but so basically 10, you are just giving a value. You should have given a variable, that is you should have written p equals and of a. So if you write and of a, then it would have pointed to the variable a, but you cannot write 10 because 10 does not mean any particular memory location, right? It's just a value. It's not even stored in any memory location, or a is a memory location because it's a variable, so it has a memory location in the RAM. But 10 is just a value. It's not necessarily a memory location anywhere, right? So this will give you a compilation error. Is that clear to everyone? Okay. All right. Now again, a few more miscellaneous questions. So we have the following code. It is a string. So hello, comma, space, world, exclamation mark. That's our string str. And then you are defining a pointer ptr, character pointer, which is pointing to the first element of str, right? That is what this sentence, this statement means. So this is a character pointer ptr which will point to the first element of the string. Now you are printing star percentage s slash n ptr plus 7. So what do you get here? Okay, Option D. Okay, let's check that out. All right, so PTR plus n. Initially, PTR was pointing, so PTR is pointing here to H, right? And I'm writing the indices of this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and there'll be a null, right? A null, which is 13. Okay, because it's a string. All right. All right. Now, when I'm saying PTR plus 7, what does that mean? Increment PTR by, like, not increment. So this is PTR plus 1. This is PTR plus 2, PTR plus 3, PTR plus 4. So PTR plus 7 is this, right? This is PTR plus 7. And percentage S, basically I'm saying that we will start printing at PTR plus 7. So PTR plus 7 is W. So we'll start printing from W. So it will be what will be printed? WORLD exclamation. Then it encounters null. So the printing will stop there. So answer is option D. Uh, you have correctly answered this. So answer will be world followed by an exclamation. Is that clear to others? Okay. So the next is a theoretical question. So which of the following is a disadvantage of the trapezoidal rule? So it's computationally expensive, it's accurate only for certain types of functions, it can produce inaccurate results for functions with rapidly changing curvature, and it requires a large number of subintervals to achieve high accuracy. Right. So if you have a function in which the curvature changes very fast, like it is like something like this, then it will be very difficult for you to use the trapezoidal rule, because the definition of the trapezoid, you will have to consider very small trapezoids, like the height of the trapezoid will be very small in order to get any semblance of a correct result. Otherwise, if the curvature keeps on changing like very rapidly, you're going to get uh, very inaccurate results with the trapezoidal rule. So that is a case where we don't prefer to take trapezoidal rule. Okay. All right. Okay. So next, okay, I have only a single question about file handling. So we had one lecture on file handling. So there we looked at how to use this fopen, fclose, and fwrite, and so on. So fopen, so this is our file name basically, right? And this is the mode of access. So basically, this here we are specifying that I am going to read this file hello. So hello is the name of the file, and I am giving reading access only. So I can only read the values, that is value or data that is stored in the file hello. Okay, so the question asks here that what does fp point to in the program? So fp is a file pointer. Option B or D. Okay, so yeah, you're correct. The answer is option B. So a file pointer is a special type of point. It's not a pointer actually. It's a structure. So file pointer is a structure which has been type deft in stdio.h. If you open stdio.h, the file, you will see that there is a type def definition of this file. This The file is actually a structure. in stdio.h. It has been defined as a structure. Okay, and type def means it's a new data type that has been declared on top of the structure. Okay, so when you say file, it automatically opens a structure, and in the structure are a lot of components. So what are the components of this? The components are, you have the name of the file. Okay, then you have the mode of access of the file, you have the location of the file, and the position, the current position in the file. So which position are you currently pointing to, or you are currently at? So these are the four things that are being stored in this structure called file. So this is a structure which contains a character pointer which points to the first character of the file, which is currently the current position. So this is the character pointer it is talking about. Okay, so this is the character pointer which points to the current position. Current position means initially when you are just opening the file, it will point to the first, character of the file. Then you can change it by using fseek or whatever other functions you want. And the name of the file, like here, it will save it as hello. The mode of access, it will save as add reading access, writing access, read binary, write binary. There are many different modes. It will save it again as a string. So this is a string, this is again another string, and location of the file is also a string, and current position is a character pointer. So it is a bunch of character pointers, you can say, the file. So that like the components of the structure called file. Okay, so this is how you open a file. So like you have opened the file called hello. Now if you want to close the file, you write fclose and fp, the pointer, the file pointer, you just write it fclose in braces fp, that is the file pointer. So that will just close the file. Okay, so is this clear? Okay, all right. Now I have one question on dynamic memory allocation, but I'll be very briefly, I'll go over dynamic memory allocation. So the part that we are concerned is with malloc, calloc, realloc, and free. These are the four commands that we'll be using mostly for dynamic memory allocation. So as this dynamic memory allocation specifies, the memory is allocated during runtime. Okay, the memory is allocated during runtime. So normally when you define int x or char c, this is memory allocated during compile time. Okay, so when you are compiling the code, then itself the memory is getting allocated. Okay, but in dynamic memory allocation, only when you execute the code, only then the memory is allocated. So why do we need this? We need this when we don't know what is the size of. So whenever we are using, uh, so you have an array. Okay, you want to have an array, the size of which will be inputted by the user. So I don't know what is the size of the array. What is the size of the array going to be? So I can use this realloc function here to increase my size based on what the user gives. Okay, so dynamic memory, basically I can change the array in between also. While the code is running, I can decrease the size of the memory allocated or increase it as I require. Okay, I don't need to specify it from the very beginning, like in compile time case, where you need to give all the size and everything from the very beginning. So during compilation time only you have to specify. But here you can your memory can be allocated and deallocated, reallocated during runtime. Okay, so it is much more flexible. It gives you much more flexibility, but at the same time it slows down the code. So compile time memory allocation will be always faster than dynamic memory allocation. Okay, because you are specifying how much space you need, so it will be already the program will already give you that much space in the RAM. But in dynamic memory allocation, you keep on you specify the amount of space you need during runtime, and you also keep changing your demands of space. So that will cause a overhead, that will cause some time, that will require some time for the program to again reallocate you space and so on. So dynamic memory allocation is always slower than static memory allocation or compile time allocation. Okay. Now malloc and calloc are the two functions that are used to allocate space in dynamic memory allocation. So here is an example of the malloc function. So the format of malloc function is that you define malloc and the size required. Okay, how much size you require. So here I require 5 into size of int, so I require 20 bytes of space. So I'm assuming a 32-bit system. So that means I am saying that give me 20 bytes of space. So what malloc will do is it will allocate required space and return a void pointer pointing to the first byte. Okay, so pointing to the first byte, it will return a void pointer back to you. So but I need it because I am going to store integers. I know, like, my intention is to store integers. So I need to convert the void pointer. I need to typecast the void pointer to an integer type on like integer type pointer. Only then I can access integer values, right? So I need to use this part. I'm forcibly typecasting. So here I am typecasting void pointer to integer pointer. So this is the purpose of this int star. So only this malloc 5 into size of int or whatever space I write here, it will only allocate that required space and return to me a void pointer which is pointing to the first byte of that space. Okay, but I know that I want to use it for integers, for storing integer values. So for that I need to redefine that void pointer or typecast that void pointer to an integer type pointer. So that is what I do, and then I store, and this is the pointer basically, this ptr. Okay, this ptr is the integer pointer that this malloc typecasted after typecasting it will give. Okay, now that is what will happen. How does it happen in calloc? The same thing. If I want to write in calloc, I will write it like this: in int star ptr equals int star calloc 5 comma size of int. So what different thing I have done? I have, so calloc takes two inputs. Okay, first is the number of elements and size of each element. So it is more of an array kind of approach where you are having this elements of equal sizes. So I'm saying I need 5 elements of the size of int, and calloc has a specialty that it will initialize the values to 0. Okay, that is only in calloc. Malloc will not do that. Malloc will not initialize the values to 0. Malloc will not initialize to 0. Initialize values to 0. Okay, only calloc will do that. And because of this initialization, calloc is slower than malloc. Because of this initialization part only, the calloc function is slower in allocating memory than the malloc function. Okay, but it will initialize the values to 0. If you use malloc function and you try to access the memory location, it will give you garbage data. It will just print garbage values. So because there is initially nothing, it will just give you garbage values. Okay, but if you define, if you write this calloc function and then you try to access the data, you will get the value of 0. Okay. All right. Now, next is the realloc function. So realloc function, what does it do? If you want to change, so realloc also works in a similar way. You just write the new size you require. Okay. I think, wait, this is not the format. So you write the pointer PTR and new size required. Okay. So this is the realloc function. The same thing, I mean the rest is still the same. I want to save it in the same pointer or in a different pointer, that's up to me. So here I'm saying that I want this pointer to be now say 40 bytes, not 20 bytes, I want 40 bytes now. So I write realloc. First, the first argument is the pointer, the previous pointer value, like the previous pointer, and then I say the new size that I require. So I just put that, and then I can choose to save it in the same pointer or define a new pointer. That is up to me. So realloc will basically reallocate space. So this is important because this is a beauty of dynamic memory allocation, where you can change the space requirements in between the code also. This you cannot do with a static memory allocation or a compile time allocation. You cannot do this. But with dynamic memory allocation, you can use realloc function to change the space requirement that you have. Now free, the last one is free. So basically to free the pointer. So if I have this pointer PTR, to free the memory, okay, to free the memory, I can use this free function. Free in parentheses, I just write the pointer. So this will free the memory. Okay. Now that we have seen all the different functions associated with dynamic memory allocation, let's look at the question. So here I am asking malloc to allocate me 5 into size of int, so 20 bytes of space, and I am putting it into a integer, typecasting into integer pointer. Okay, and now I am saving some values to this dynamically allocated array, and I'm doing quite a few post and pre-increment operations. So what should be the output here? Are you sure? Here look at the increment and decrement that is happening. So that is pretty important. So what is this going to save? Like this, what is this array? So it is going to be 1 2 3 0 1 2 3 4, right? So your loop will go from 0 to 4, and you are saving ptr plus I equals I. That means first element is 0, second element is 1, third element is 2, and so on. So this will be your array. Okay. Now the first statement was it, what does it say? Star ptr plus plus. So for this, I will take your attention back to the operator precedence. Operator precedence basically pre and post increment decrement operation has a higher precedence than the referencing operation or dereferencing operation. Okay, so this is the operator precedence. So post and pre-increment operation has a higher precedence than the dereferencing operation. So keeping that in mind, so this will be ptr plus plus with this ptr plus plus, that is post increment, followed by a star. Okay, so post increment basically means what? It will be incremented later. First the other operation occurs. So other operation is what? PTR is pointing here, right? The first element, that is 0. It is pointing to the first element, the PTR. Okay, now I say PTR plus plus as in post increment and then star of PTR. But the nature of post increment is that First the other operation will occur and then the post increment will occur. So star ptr will give me 0, that will be the first value, and then ptr plus plus, not star ptr plus plus. Okay, so this will be basically star ptr followed by ptr plus plus, not star ptr plus plus. You have to keep this in mind. Star ptr plus plus will mean that I am increasing the current wherever it is currently pointing to. I'm increasing the value by 1, but I'm not doing that. So here it is it is ptr plus plus. That means the pointer itself, it's going and pointing to the next one. So instead of pointing, so instead of after this statement, instead of pointing to 0, it is going and pointing to 1. Okay, so the pointer is going and pointing to 1 now. Alright, now that is the second element. It is pointing to the second element now. Now what does the second line say? Now we have put the star ptr in braces, in parenthesis. So this will be executed first and then the post increment will happen. So what is the star ptr? Star ptr is a value, right? And what is the value? Value is 1. But it is a post increment operation. That means first it will do the printing and then it will increase the value. So here it will print star ptr and then do star ptr plus plus. So if it prints star ptr, ptr is a pointer pointing to the second element currently. So first it will print the value at this element star ptr, that is 1, and then it will increment this to increment the second element by 1. So it will now become 0, 2, 2, 3, 4. That is what it will happen. Then the next printing is star ptr. Okay, so here still we are, ptr is pointing to the second element only. The value has increased, value of the second element has been incremented by 1, but the ptr is still pointing to the second element. Okay, now we just print star ptr. So that means the value which wherever the ptr pointer is pointing to, that is 2, right? It is pointing to the value of 2, the second element. Now next what we do is star plus plus ptr. It's a pre-increment operation, and pre-increment will happen first and then the dereferencing operation will happen. So ptr, instead of going so what will happen here, it will be plus plus ptr. That means the pointer will be incremented, not the value, followed by star ptr, printing of star ptr. Okay, so plus plus ptr will make this ptr pointing to the second element to now point to the third element, right? It will go and point to the third element now, right? Plus plus ptr, the ptr which is pointing to the second element earlier will now point to the third element. The third element is also 2. Okay, and that is what is being asked. Star, now after this plus plus ptr is done, it will be followed by star ptr. What is star ptr? 2, and that is what will be printed. So 2 will be printed. Then in the last one, even if you write it as plus plus star ptr, the same thing will again happen. It will be plus plus ptr and then star ptr. So it will, instead of pointing to the third element, it will be incremented and it will point to the fourth element now. So it will go and it will point to the fourth element. Okay, and the value, and then star ptr, that means this, the value at wherever this pointer is pointing to, and the value is 3. So 3 will be printed. So the answer will be 0, 1, 2, 2, 3. Is it clear how this is happening? This one? Yeah, first increment, but in increment of the pointer, not of uh, the pointer variable, not of the value stored at the pointer. So like I said earlier, right, the pointer will point to the next memory location. So when you are saying this plus plus ptr, that means the pointer will go and point to the next memory location. Okay, and then when you do the star ptr, it will be the value at that new location. Is it clearer now? It's not? Okay. uh, Fine, let me explain this question again. So I have, this is my array. Okay, I have defined it statically, dynamically, however, doesn't matter. So my ptr is pointing to this. Okay, let me start in a corner so that it will be easy after I can rewrite the array after each one. Okay, so let's write down my array again. 0 1 2 3 4. So this is my array, and I have a pointer ptr pointing to the first element. This is so far so good, right? Now the first printf statement is star ptr plus plus. Okay, this is what I am trying to print. So here onwards I'll just be writing the printing statements. So just consider, okay, star ptr plus plus. So what happens when I write star ptr plus plus? So I can write this. So basically it will be ptr plus plus and then star ptr. Okay, but ptr plus plus is a post increment operation, so the increment will happen later on. After other operations are over, the increment will occur. Okay, so what will the ptr, uh, the post increment will occur at the end, right, at the end of the statement. So, and the other operation is star ptr. So what is star ptr? The value that ptr is pointing to right now. So 0 is that value, right? So 0 will be printed, and then the pointer ptr will be incremented by 1. The pointer will be incremented, not the value. The pointer will be incremented. That means instead of pointing to 0, now it will be pointing to 1. So this will be ptr. Okay, now the next statement, what is the next statement? You have star ptr in parenthesis, then plus plus. So this, uh, ideally the post and pre increment have a higher operator precedence than the dereferencing operator. Okay, but in this case you have put the parenthesis. So first whatever is within the parenthesis will be will be used and or will be calculated, and then the whatever is outside will be calculated. So here star ptr, that means you are referring to the value now. You are not referring to the pointer. You are referring to the value, because star ptr, to when you write, it refers to the value that the ptr is pointing to, and ptr is pointing to the second element of the array. So you are referring to the value. So star ptr is 1. So this is a post increment operation. So first the printing will occur and then the increment will occur. Okay, so if the printing occurs, what is ptr pointing to? 1, right? The value is 1. It is pointing, star ptr is 1. So I am basically writing the second value and with a plus plus, that is a post increment. So the second value will be printed and then it will be incremented by 1. So it will become 2, and the ptr is still pointing here. Okay, now next I am printing star ptr. Star ptr basically means whatever it is pointing to, it will just print that value. It is referring to that value. So 2. Okay, so nothing, no changes in the pointer pointing to. So the pointer is still pointing to the second element. The value of the second element is 2. Now what is the next statement? The next statement is star plus plus ptr. It's a pre-increment operation. So this, how will this be? This will be plus plus ptr and then star ptr. Okay, so when you say plus plus ptr, that means what? The pointer will be incremented by 1 and then you are saying a star ptr. So 0 2 2 3 4, this is what it was. the pointer will go from pointing to the second element to the third element. It will start pointing to the third element because you have done a plus plus PTR, which is a pre-increment operation. The pointer will now point to the third element instead of the second element. Okay, and then you're saying star PTR. So what is the value in the third element? The third element, the value is still 2. Okay, and the last thing that you're doing is plus plus star PTR. So even if you write it like this or like this, it's the same thing. The operator precedence does not change. So this is still plus plus PTR and then star PTR. This is what will happen. So plus plus PTR, what will that do? So that will make your pointer point to the fourth element instead of the third. Yeah. Pointer is not incremented because you are only incrementing the value. So this star PTR in braces, the parenthesis, you are referring to the value only, not to the pointer. Okay, but in all these other cases, you are referring to the pointer itself. Okay, because the plus plus, the pre-increment and post-increment operations, the operators have higher precedence over the dereferencing operator. So unless you put it in the bracket like this, you are not referring to the value, you are referring to the pointer unless you put it in parenthesis. Okay, so in the last case, this it will start pointing to the fourth element, and that is what will be printed when you say star PTR. That will be the value at the fourth element, that is 3. So it will print 0 1 2 2 3. So that is our answer here. Okay, all right, it's yes. In the fourth, yeah, yes. uh, No, depending on the code, because here I wanted to store 5 integers into my array. Like I want to create an array with 5 integers. So I said just give me 20 bytes of space, which is basically five. I want 5 integers and whatever the size of int. I know that I am going to store int values, like integer values. So I'm just saying to the code that give me or allocate me space where I can store 5 integer values. So that is what I have said here. 5 into size of int. Say if I want to save 5 double values, so I will say that malloc 5 into size of double, because I want to save double values, so it will require more space. So it will give me 40 bytes of space. Okay. Yeah, yeah. uh, for each array, like here I want an array like the way you used to define, say, float arr 1 of 10, right? So what does this mean? This is defining an array of 10 elements. So a floating point array of 10 elements, right? Floating point array of 10 elements. Similarly here, what I will do is I will write float star ptr equals float star malloc 10 into size of float. So it will allot me a floating point array of 10 elements where I can store 10 elements. Okay. Yeah. Any other doubts regarding this or any of the things that we covered in today's class? Okay. If not, then I will close this session here. Oh, f open. So f open is basically a function. Okay, let me go back to the slides. All right, f open. So f open, f close, f write, f seek. These are all functions that are defined for file handling. So f open is a function which is used to open a file. This will open a file, and its format is file name followed by mode of access. Similarly, fclose is a function used to close a file. Okay, and fwrite you can use to write into a file. Fseek is a function you can use to move to a certain place in a file. And so on. Like there are many different uh, file handling operations or file handling functions available to you in the standard stdio.h library. So fopen is just one such function which is used to open the file. Fclose is used to close the file, and so on. Like this, there's just a standard library function. All right. You're sharing a code, okay? And mhm. Uh-huh. It is using the AND operation. This is bitwise AND operation that you're doing, right? Okay, okay. So we can do this very quickly. Okay, so your code is x equals 5, then x and equals 3, right? So this I can write as x equals x and 3. So this is a bitwise AND operation. And okay, so first for bitwise operations, what we do is we write everything in binary first. So 5 if I write in binary, what will it be? 5. Okay, yeah, cool. Similarly, 3 if I write in binary, what will it be? 3. 1 and 1, right? 0 1 1, right? Now you do bitwise AND of all of this individually. So 1 and 1 will be 1, 0 and 1 will be 0, 1 and 0 will be 0. So the answer will be 1. So here if you do, basically you're doing this, right? This will give you 1, right? 2 to the power 0, 2 to the power 1, 2 to the power 2. Multiply it. So I mean this is still binary, right? You have to convert it back to decimal. So multiply, add. So multiply with 2 to the power 0, 2 to the power this 0 with 2 to the power 1, 0 with 2 to the power 2, then add it up, then you will get 1, just the decimal part. Okay, so 1 will be the answer. Is it clear now how you do it? Yeah, the same thing if yeah, I mean the OR operation is similar. Like if I do 5 or 3, so instead of doing AND here, so if I do that, it will be say OR. Yeah, it will be single this one. Okay, yeah, so this will be 1, this will be 1, this will be 1. Okay, because OR is either of them. If it is 1, the output will be 1. So 1 1 and 1. So this will be 2 to the power 0, 2 to the power 1, 2 to the power 2. Just multiply and add. So 2 plus 1 plus 2 plus 4. So that will be 4 plus 2 plus 1. That will be 7. So this will be 7. Okay. Okay. Now the other bitwise operation is greater, like it's not greater than and less than. It's shift. It's a shift operation. Okay. So like let's say I'm not shifting it by 3, but rather let me shift it by a lower number. Probably you will be able to understand it then. So basically this means that I'm shifting 5 by 1 place. Okay, now let's say I'm writing the bits now. 1 2 3 4 5 6 7 8, 8 bits, right? Constitutes 1 byte, 8 bits. So I have 8 bits here. So let me populate it with 5 first. So 5 is 101, right? 1 0 and 1. The others are all 0 0 0 0 0. Okay. Now I am shifting towards the right by one space. So this last bit will be lost and everything will shift by one bit. Okay. So if I rewrite this, so this will all still be 0. This will be lost. This will move here. So this will become 0. This one will move here and all these zeros will move and there will be another 0 coming from here. So this will be 2 to the power 0, 2 to the power 1, 2 to the power 1 is 2. So this will be 2. Is it okay? Sorry? Yeah, so this is the XOR operation. Okay. Uh, so you have written something like this. This is basically x equals x XOR 3 and say x is 5. So I'm going to do the same. So first x is 5, right? So 5 XOR 3, that's what I'm doing. So 5 is 101 and 3 is 011, right? So I'm doing a XOR operation here. So in XOR operation, if either one is okay, so let me write the XOR table. So the outputs are 1 and 0, then it will be 1. If it is 0 and 1, then it will be 1. If both are 1, then it will be 0. If both are 0, it will be 0. I think that's the XOR table. So we will follow this. So this is A, this is B, this is output. Okay, this is the XOR table. So this will be 0, this will be 1, and this will be 1. So 2. So now you convert it back to decimal. 2 to the power 1, 2 to the power 2. So this will be 5. Right? 2 plus, oh sorry, no, 6. This will be 6. Is that clear? Yeah. So these are all the bitwise operations basically. Bitwise and assignment operations combined. Yeah. Yeah, sure. So any other doubts? Okay. If not, then let's close the session here. And like I said, good luck for your final exams. I hope you do well. Thank you for joining.